This paper relates to pinewood crib fires and the measurement of toxic emissions using a 5-meter cube compartment fire, which is a scale up of a 1.5 meter cube compartment fire that we've used for several years at Leeds. This is the diagram of the test facility. It has an observation window here. The fire load in the middle sits on load cells. This is the crib we were using, quite a large crib made of 20mm square pine sticks, total weight just over 6 kilograms. It's a restricted ventilation compartment. There's an air box underneath and air access here through a controllable slot, which was smaller than the vent in the ceiling. So the air access was controlled by the lead here. The size is 5% of the cross-sectional area, or the V to the 2/3 of the compartment, a factor we've called a ventilation KV factor in the past. So it's highly restricted ventilation. We can sample the gases from the ceiling layer coming out the vent here. And we have a 40-hole probe that takes a mean gas sample. The heat release by oxygen consumption, the fire starts growing, and it doesn't know it's in a compartment because it's full of air to start with. So it consumes the air and then slows down. So you can see here's the reduction in oxygen, and then we get a roughly steady state part of the fire. But this is a fire that self-extinguishes, and we'll see the most toxic part of this fire is in this phase, going from a heat release here to no heat release. And as we run out of oxygen there, originally the temperature drops. We're talking about a 250 degrees centigrade fire. Oxygen levels when we extinguish, it's about 10%. The global fire equivalence ratio is lean throughout. We will see high CO, but not due to rich combustion, due to inefficient combustion. And so when it extinguishes, we've got a global equivalence ratio of about 0.5. This is the toxic emissions of CO, burning lean at the start. So when the fire accelerates, very low CO. And as it runs out of action, the CO comes up. And this period just before extinguishes, highest CO. The total hydrocarbons, or the total volatiles driven off from the wood, also peak at the same stage. This is some of the yields, and CO yields are very high, as high as you've had in bigger compartment fires that burn rich with more ventilation. You'll also see, we'll come back to this, the huge yield that comes with that period just before self-extinguishing. We look at these CO yields. This is a whole lot from the literature, including quite a lot of our own work. This is a 40-meter cube, full-size compartment fire we published on that the test had the door open to this compartment. It does go rich. This is the classic Chewison data. Here's the data in this compartment. We have got the highest CO yield for lean burning anywhere, and the peak CO yield just before we self-extinguish is as bad as Chewison had for very rich mixtures. This is the toxics, and you'll see it's peaking in that period just before self-extinguishing. This benzene peaks. Formaldehyde has been growing throughout the period where oxygen is depleted and the temperature is falling, reaching a peak there. Acrolein behaves different. Suddenly shoots up in that period on the way to extinguishing, and we also get a peak in HCN at the same time. If you take the toxicity for each of those components and divide the concentration by the limit, then you get what's known as an N factor. We do that to each species and add them up, you get a total N. We've done that here for LC50 on this line with the scale over here, and we're using COSH 15 minute for impairment of escape. And you can see the huge toxic peak, but impairment of escape coming in at around 100. As soon as the flaming combustion's over, you start to deplete oxygen. This is the percent contribution to that toxicity, and it's fairly straightforward in that for deaths, it's formaldehyde and CO, but early on it's mainly formaldehyde with a significant contribution from HCN, which we think the pine in this case had some form of polish on it, and it's probably from that surface finish. But the formaldehyde being more important to the CO early on. We look at impairment of escape, then acrolein and formaldehyde totally dominate that impairment of escape early on. This is a massive increase in acrolein just before extinguishing. But when this fire has gone out, we've got smouldering combustion, we've got hot pine but no flame. You can see the atmosphere is still incredibly toxic, dominated by acrolein and formaldehyde. In conclusion, we've got high concentrations of toxics in this air-starved fire with only 5% of the cross-sectional area available for air to come in at the base of the fire. Peak toxicity occurred just before the flame out. CO, acrolein, formaldehyde, benzene, HCN are it's really these three that dominate, and the others are measurable. And high yields of CO for lean burning. We've been making this theme in several papers that lean low temperature compartment fires have high yields of CO, and in this paper we're publishing the highest yields that we've seen and the highest in the literature for lean burning. And the fact that once the fire has gone out, these compartment fires are still highly toxic. The hot smouldering combustion is producing high levels of CO, acrolein and formaldehyde. Thank you.